Welcome to this lesson on the distributive property part 1. Please make sure you have these notes in front of you so we can begin our lesson. And my students, let's make sure we update our table of contents. This lesson has two learning objectives. The first one says I can use the distributive property to multiply numbers. And the second one says I can use the distributive property to express a sum of two whole products. So in order for us to go ahead and understand how to solve the learning objectives, we're going to have to know what the distributive property means. And the distributive property means a number multiplied by a sum or difference. So remember, sum means to add and difference means to subtract. So if in algebra, this is what the distributive property looks like. I'm going to have a number on the outside times the quantity, and anytime I say quantity, I'm referring to a set of parentheses, B plus C. So the distributive property means to take the number on the outside of the parentheses and multiply it with everything on the inside. So A times B will give me AB. There's a plus sign in there, so I'm going to write a plus sign here. Now I'm going to multiply A times C, which looks like AC. So that's what it looks like multiplying a number by the sum. Let's look at multiplying a number by a difference. So I'm going to use A parentheses B minus C, close my parentheses. So when I distribute, I'm going to multiply A times B. That gets me AB. There's a subtraction sign in there, so I'm going to put subtraction sign there. And then I'm going to multiply A times C, which is AC. So this shows me multiplying a number by a difference. Now for the key concepts, you're going to end up drawing your own models, or using the models to help you solve these problems. So you might be given a problem that looks like this. You would draw a model that has two boxes long, and since I have parentheses, these numbers are going to go on the outside of the model. So the A would go here, and usually the A is the greatest common factor. The greatest common factor would go on the left-hand side. The B would go down here, the plus sign would go down here, and the C would go down here. Another problem that you might have would look like this. AB plus AC. Notice that this problem doesn't have any parentheses. So if this problem does not have any parentheses, then in the model, instead of placing the items on the outside, you would place these items on the inside. And your job is to figure out what the GCF would be of those two numbers. So let's go ahead and use these key concepts to discuss the following examples. Let's take a look at example 1, which says multiply 7 times 36 using the distributive property. What I want to do is I want to look at 36 and I want to break it up, because 7 times 36, yes, we can go ahead and multiply it like this and we can get an answer, but we can also break 36 up so we can make our life a little bit easier. So what I can say is I can break 36 up into 30 plus 6. It's still equal to 36, it just looks a little different. And I'm going to write this using the distributive property. So I'm still multiplying it, so I'm going to write 7 times the quantity of 30 plus 6. This is still saying 7 times 36, because 30 plus 6 is still equal to 36. And we're still multiplying, because anytime the number is standing next to the parentheses, you're assuming that you're multiplying. So now we can use the distributive property to multiply this. So using my model, I notice that I have parentheses here in this problem right here. What I can do is I can assume that these are the outside numbers of my model. So the 7 is going to go here. The 30, that's how long this side from here to here is worth 30. And the last part of the box is worth 6. So this is saying 30 plus 6 on the bottom, and this side is worth 7. We can find the area of the first rectangle by doing 7 times 30, which is 210. That's the same thing as us doing this, 7 times 30, which is still 210. Now we're going to have to multiply 7 times 6, so the area of the second rectangle would be 42. 7 times 6 is still 42. Now let's go ahead and find the total area of both rectangles. So we would have to multiply both, or add both numbers together. and our answer would be 252. For example 2, let's go ahead and multiply 6 times 12 using the distributive property. So let's go ahead and break up 12 to make it look using nice clean numbers. I can say 12 can be broken up into 10 plus 2. That's still equal to 12. It just looks a little differently. And since I'm multiplying it with 6, I can go ahead and use the parentheses to group these and have 6 on the outside and still multiply it. So since I have parentheses in this problem right here, I can assume that those numbers go on the outside of my model. So I'm going to place a 6 here. This side is worth 10. This is my plus sign right here where that line is. And this side is worth 2. Let's go ahead and find the area of these two rectangles. So the first rectangle would be 6 times 10. 6 times 10, which would be 60. That's the same thing as us doing this. 6 times 10. And we still get 60. Let's find the area of the second rectangle, which would be 2 times 6. Or 6 times 2, which is 12. That's the same thing as us doing 6 times 2 up here. And let's go ahead and add them up. If we add all the numbers inside the box, we get the total area of 72. Now for example 3, it's asking us to multiply 9 times 4 and 1/3 using the distributive property. And we're going to use the same concept that we've done before. Let's go ahead and break up 4 and 1/3 into 4 plus 1/3. That's still equal to 4 and 1/3. We just separated the numbers, or we broke them up. And since we're multiplying it, we're going to group these together and write the 9 on the outside, and we can assume that we're multiplying it because it's standing next to the parentheses. Since I have parentheses in this problem, I can assume that these numbers go on the outside of my model. So this side is worth 9. This side is worth 4. This is my little plus sign here. And the last part is worth 1/3. So let's go ahead and find the area of both rectangles. The first thing I would do is I would take 9 times 4, which is 36 in here, which would be the same thing as doing 9 times 4 here. That's still equal to 36. Then I would take 9 times 1/3. So you can do 9 times 1/3 like this. Cross cancel, 3. My answer would be 3/1. So this is worth 3. I can do the same thing and say 9 times 1/3 is still equal to 3. So the total area of both rectangles would be equal to 39. So now it's time for some comics.
I have a candy bar.
Hey man, can I have 5/10 of your candy bar? So go ahead and pause the video and complete these Got It problems, and we'll discuss the answers in class tomorrow. Notice we have 3 Got It problems on this slide. We've got It problem A, B, and C. And please solve this using a model. For example 4, it says use a model and the distributive property to solve the product of 2 factors. We know that this is a product of 2 factors because product means to multiply, and I'm multiplying the 6 with the 2 factors on the inside of the parentheses. So the 2 is a factor and the 1 is a factor. Notice that this problem has parentheses. So I know that these numbers will go on the outside of my model. So this is worth 6. This side is worth 2. This is my plus sign, and this side is worth 1. Let's go ahead and find the area of the first rectangle, which is 6 times 2, so this becomes 12. And that's the same thing as us doing 6 times 2 up here using the arrows. It's still 12. Second area would be 6 times 1. 6 times 1, which would be 6. Same thing as us doing 6 times 1 up here. And 6 times 1 is still 6. So if I add these two numbers, my area would be 18. Or my answer would be 18. Example 5 says use the model and the distributive property to solve the product of 2 factors. I know that this is the product of 2 factors because when the 2 is standing next to the parentheses, that means multiply or means product. So we're going to multiply with the 2 factors on the inside of the parentheses. 34 is a factor and 26 is a factor. So because this problem has parentheses, I'm going to assume that these numbers go outside of my model. So the 2 goes on this side. This side is worth 34, and this side is worth 26. But notice this is a subtraction problem. So let's go ahead and write a minus sign right between them. So let's go ahead and distribute the areas. 2 times 34 gets me 68. That's the same thing if I was to do 2 times 34 up here. I still get 68. Let's go ahead and find the area of the second rectangle, which is 2 times 26. 2 times 26 would be 52. Same thing if I was to do 2 times 26 here. I still get 52. But notice there's a subtraction sign in the inside, not an addition like the other problem. So let's go ahead and write a subtraction sign here. So we need to make sure we subtract the two numbers inside the model. So 68 minus 52 is equal to 16. And that's our answer. So go ahead and pause the video and complete these Got It problems. And we'll discuss the answers in class tomorrow. Notice I have two Got It problems, Got It problem D and Got It problem E. Let's make sure we show a model to support our answer. So let's go ahead and express the sum of two whole numbers as a product using the model. So we know anyone can add 52 plus 68. That's not what this problem is asking. They want us to write it in a different form. So notice this does not have any parentheses. No parentheses here, so we know that these numbers do not go on the outside, they go on the inside. They're giving us the area. So this area of the first rectangle is equal to 52, and the area of the second rectangle is equal to 68. Our job is to figure out the numbers that go on the outside of the model. Let's use the ladder to find the greatest common factor of 52 and 68. And the greatest common factor would be 4. So the greatest common factor would go on the left-hand side of our model. So let's write the 4 here on the left-hand side. And in order to figure out the other side, or the missing sides of our model, let's go ahead and divide the area by the greatest common factor. So 52 divided by 4 is equal to 13. And you can check your answer because 13 times 4 is equal to 52. And then you can say 68 divided by 4 gets you 17. You can check your answer because 17 times 4 is equal to 68. So I can write my answer like this. 52 plus 68 can also be written as 4 parentheses 13 plus 17. So this is how you can check to see if both expressions are equal. 4 times 13 gets me 52. 4 times 17 gets me 68. So both expressions are equal even though they look different. So now it's time for Guess What I'm Drawing. So let's pause the video and complete the Got It problems, and we'll discuss the answers in class tomorrow. So now that we've just completed the lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch it again. Also come to class with some questions so that we can discuss it in further detail.